Hi there, welcome to another video session on Math File. In this video, we're going to talk about identities and equations. If this is the very first time of visiting the channel, please take some time to subscribe to the channel and also click on the notification bell so that you get notifications on your devices whenever I post new videos. So the objectives for today is by the end of the lesson, you should be able to tell the difference between an equation and an identity. Also, you should be able to solve identities. So the first instance, you are going to tell the difference between an equation and an identity, and the next one you'll be able to solve for constants and identities. So let's start off by stating, or let me say writing a simple equation. Let me take a basic equation like x plus 3 is equal to let's say 10, and let's take another one in the form x plus 3 all squared. This is equal to x squared plus 6x plus 9. Now, on the face of this, we will say that the first instance, x plus 3 is equal to 10, and the second instance, both of them are equations. So let's look at something. For us to tell the difference between an equation and an identity, we test for values of x, which is going to make the equation true. For the first case, this equation is going to be true when x is equal to 7. This is because 7 plus 3 is equal to 10. If you simplify the left hand side, this gives you 10 is equal to 10. So since the left hand side is equal to the right hand side, 7 satisfies the equation. Let's try for another value to see if this is going to make, or let me say, give us the same thing as we got with the substitution of 7. Let's try when x is equal to, let's say 2. This becomes 2 plus 3 is equal to 10. And 5 is not equal to 10. Therefore, 2 is not part of the solution set, or you can say that 2 doesn't satisfy the equation. So with this one, you can see that 10 satisfies the equation, 2 is not satisfying the equation. And I'm very sure if you substitute more values into this equation, all the values won't give you the left hand side to be equal to the right hand side. Let's look at this side. With this one, we've got x plus 3 all squared is equal to x squared plus 6x plus 9. Let's try to make a substitution. Let's start with a simple substitution of 1. So when x is equal to 1, this becomes 1 plus 3 all squared and 1 squared plus 6 of 1 plus 9. This simplifies to 4 squared. This is equal to 1 plus 6 plus 9. 1 plus 9 is 10 plus this is 16. 4 squared is 16, and this is equal to 16. You can see that the left hand side is equal to the right hand side. Now you can say that 1 satisfies the equation. Let's move on to another variable. Let's move on to another substitution with the variable x. So let's say x will be equal to, let's say 5 or maybe 3 or maybe 2. It's a matter of choice. So let me just wipe off this. Let me wipe off this and do another substitution. Okay, so let's use 2 for the meantime when x is equal to 2. So when x is equal to 2, this is going to give me 2 plus 3 all squared plus, this is equal to 2 squared plus 6 of 2 plus 9. Now this simplifies to 5 squared. This is equal to 4 plus 6 times 2 gives you 12 plus 9. Now this is 25, and if you simplify the right hand side, so this is giving you 25. Now you can see that the first instance, x equals to 1, give us the left hand side to be equal to right hand side, and when x equals to 2, we're getting the left hand side to be equal to right hand side. So we'll try to do more substitution and see what you're going to come up with this. If you substitute 3, are you going to get the left hand side to be equal to the right hand side? If you substitute negative 2000, are you going to get the left hand side to be equal to the right hand side? Actually, the answer is going to be yes. For every value of x you put into this thing, you are going to get the left hand side to be equal to the right hand side. So any value of x is going to satisfy this equation. But with the equation on my left, that is x plus 3, this only takes specific values, or let me say limited number of values. In this case, the only value that is going to make this statement to be true is when x is equal to 7. Now this gives us the main difference between an identity and an equation. The one to my left is called an equation, and the one to the right is called an identity. This is because for equations, these equations are only true for specific number of values, or let me say limited values. But when it comes to identity, this is true for all values of x. So for any value of x you put into this expression, you are going to get the left hand side to be equal to the right hand side, as I illustrated with two values. You can substitute 0. I think 0 is even easier to work with. So 0 squared, 0 plus 3, this gives me 3 squared is 9. If I substitute 0, this goes away, this goes away, and you can see that I'm getting 9 is equal to 9. That is the left hand side being equal to the right hand side. So when you get an expression which is always true for any value of x substituted, we call that expression an identity. Okay, so that is the main difference between an identity and an equation. So an equation, it takes specific values. For identity, it takes all values. Now moving on, we're going to differentiate between the equation and identity using a symbol. We're normally going to use this symbol, let's say an equal to symbol with an extra stroke on top. This symbol implies equivalent to or identical to. So in most cases, this is what we're going to use throughout today's lesson. So it's 3 lines, which implies that it's identical to. Okay, so that's for the very first objective, and I'm very sure the objective has been achieved, because we can now tell the difference between an equation and an identity, where we can say that an equation takes specific values and identity takes all values. Okay, so let's move on to play around with some identities. Also, we also learned that instead of using the equality sign, you can use the symbol which implies identical to. So the next part of the lesson, we're going to learn how to solve for constants and identities. An example, so I'm going to use examples to illustrate this concept. An example, x plus 2 is identical to a x plus 1 plus b x minus 1. Good. So what we're going to do over here is solve for constants a and b using two different methods. One, we're going to use the cover up method, and the second one, we're going to use the comparison method. So comparing coefficients. So we're going to use the comparison method. I'm going to use the cover up method. Let's start off with the cover up method. So the main idea about the cover up method is that you want to make one of the variable disappear. When I say disappear, not to just vanish, I mean to go to 0. So looking at this thing, I've got a multiplying x plus 1, that is one constant a, and the next constant b multiplying x minus 1. What do you think for which value of x do you think is going to make b to go to 0? Now looking at this, for this to go to 0, it means that whatever is inside the bracket should be 0. When x is equal to 1, you see that you can get this one to be 1 minus 1, this gives us 0. Therefore, for b to vanish or for b to disappear, we need to make a substitution of x equal to 1. So we do this quickly by saying that let x is to be equal to 1. If x is equal to 1, this becomes 1 plus 2 is equivalent to, or let me say identical to, a, x is 1, so 1 plus 1 plus b 1 minus 1. But 1 minus 1 is 0, and 0 times any number, as we know, is 0. This can be simplified to 3 is identical to 2a. Now solving for a is equal to 3 over 2. So that is the first part of the cover-up method, because this gave me the first constant. I can do the same thing to get the other constant as well. So looking at the other constants, what do you think will be the best substitution, or let me say, what do you think is going to be the substitution that is going to make the constant a go to 0? Good, you're right. In this case, it's going to be -1. So let x to be equal to -1. When x is equal to -1, this side of the expression becomes a brackets open -1 plus 1, and -1 plus 1, as we all know, is going to be 0. So let's do our substitution. X is equal to -1. Going back to the main expression, this gives me -1 plus 2 is identical to a -1 plus 1 plus b -1 minus 1. Now I know you guys can solve from this side, but let's do it anyway. -1 plus 2, this is a +1. This is identical to, this goes to 0. -1 plus 1 is the same as 1 minus 1. This goes to 0. I don't need to write 0a. And -1 minus 1, this gives me -2. So -2b. Solving for b, you get b to be equal to -1 over 2. And this gives us the answer to the question. So we conclude nicely by saying that therefore a is equal to 3 over 2 and b is equal to -1 over 2. So let me go over the cover-up method again. The main idea about the cover-up method is that you want to make one of the constants to go to 0. So you do some substitutions, or let me say, okay, you do substitution that is going to make one of the variable go to 0. In this case, the first instance, x was equal to 1. Now, if you don't really see the number to be substituted, this is what you can do. You equate the term you want to go to 0 to 0. So in this case, x minus 1 is equal to 0, and you solve for x is equal to 1. So it means that for x equal to 1, this term is going to go to 0. Okay, so that is the cover-up method. You eliminate one of the variables, you solve for the other variable, you do the same thing for the other variable you eliminated, and you solve for that variable, and you are good to go. Now we're going to try this one using the comparison method. So the same question. So we've got the identity x plus 2. This is identical to a x plus 1 plus b x minus 1. For the comparison method, this is what we're looking out for. As the method sounds, we're going to compare. We're going to first expand, group, factorize, and compare. So we've got 4 steps. We're going to expand, we're going to group, we're going to factorize, and we're going to compare. So let's start off by doing that. In this case, let me write my x with red, and let me write my constants with blue. So plus 2. This is identical to, now expanding the side, this is ax plus a plus bx, this is 1 plus bx minus b. Now I can group this ax plus b plus a minus b. Now at this side I can factor out x. So this is a plus b, and x goes out, plus my constants, and my constants a minus b. Sorry, let me take off this. yes, a minus b. And these are constants because we don't have any variable attached to them. If I have to write my left hand side, is x plus 2. Now we're going to compare x to x and with variables without x to the constant term. In this case, you can see that there is x, but the coefficient of this x is 1, and there is a constant, So I match the 2 to the a minus b and match the a plus b to 1. Or in other words, you can say that we're comparing the coefficients. We've got a plus bx is equal to 1x. For convenience purposes, let me write 1x. This x cancels out this x, which gives me a plus b is equal to 1. So the first statement I wrote over there, you don't really need to write the statement. You can do the comparison straight away. That is, a plus b is equal to the coefficient of x in the left hand side should be equal to the coefficient of x in the right hand side, and the constant term in the left hand side should be equal to the constant terms in the right hand side. So doing the comparison, I can say that a plus b is equal to 1, and also a minus b is equal to 2. Now this gives you two sets of equations to solve simultaneously. You can solve this using any method you want. In this case, I think elimination method would be better. So I sum up the two equations. This is going to get me 2a is equal to 3. b goes to 0. Solving for a becomes 3 over 2. And substituting this into any of the equation, doing my substitution, let me say put a is equal to 3 over 2 into equation 1. This will get me 3 over 2 plus b is equal to 1. b is equal to 1 minus 3 over 2, and you solve for this one, and this should be negative 1 over 2. This should be negative 1 over 2. So b is equal to negative 1 over 2. So you can see using we used two different methods and we arrived at the same answer. The previous question we got a to be equal to 3 over 2 and b to be equal to the same question, using the cover-up method, we got a to be equal to 3 over 2 and b to be equal to 1 over 2, negative 1 over 2. And in this one we're getting the same answer. So it depends on the method you use. At times you need to use both methods in one question for you to finish up solving the question, but in most cases, if you have to choose between the cover-up method and the comparison method, I will always choose the cover-up method because I think it's faster for me. So it depends on you. You have to do more practice on this one to know which method best suits you. But like I said, there are some examples or there are some questions that will require you to use all the two methods. So let's take another example and play around with this example. Again, we've got the identity. You can pause the video and play around this question and come back in about a minute or two to watch the solution to this one. So we're solving the identity 5x minus 4 identical to a multiplying x plus 2 plus b multiplying 2x minus 1. So we're solving this one. Okay. Now let's use the cover-up method. For the first instance, I can see that when x is equal to negative 2, the constant term a, the a term goes to 0. So I'm going to do the substitution so that that term goes to 0, so that I get the opportunity to solve for one of the constants. So doing the substitution, this gives me 5 of negative 2 minus 4. This is identical to a of negative 2 plus 2 plus b multiplying 2 of negative 2 minus 1. This simplifies to negative 14 is identical to, this goes to 0 and this goes to negative 4 minus 1. This is negative 5. So negative 5b. Now at this stage, you know what to do. You can divide both sides by negative 5, which gives me b to be equal to 14 over 5. So that solves for the first one. So like I said, I noticed that when I substitute negative 2 into this expression, the constant term a is going to go to 0. So I take advantage of that fact and do that substitution. This goes to 0, and I'm left with only one variable to solve, one constant to solve for. Sorry. So doing that, I can easily solve for that constant, and that is the first way to eliminate one of the variables. Sorry, the constant. Now the next one, again, I'm going to do a substitution. Let's x to be equal to 1 over 2. Like I said previously, if you don't know the value to be substituted, all you need to do is to equate that expression to 0 and solve for x. 2x minus 1 is equal to 0. And if you solve for x, x is going to be equal to 1 over 2. This implies that when I substitute 1 over 2 into this function, or let me say into this expression, this term is going to go to 0. So that's another way to get to know the value to be substituted if you can't see it straight away. Okay, so let x be equal to 1 over 2. Doing my substitution, this should be 5 of 1 over 2 minus 4 is equal to a 1 over 2 plus 2 plus b 2 of 1 over 2 minus 1, and that ends the substitution. Now we're going to simplify this one. 5 over 2 minus 4, this is negative 3 over 2, is equal to 2 plus 1 over 2, this is 5 over 2, 5 over 2a, and this goes to 0. Now I can clear the denominators or the fraction by multiplying through by 2, or better still, since these are fractions and the denominators are equal, you can equate the numerators. So negative 3 is equal to 5a. Now solving for a is equal to negative 3 over 5. So that is the cover-up method for you. We eliminate one of the variables. Why do I keep saying variables? I mean constants, by looking at the value to be substituted to make the other constant go to 0. Now let's solve the same question using the comparison method. Let me get the identity. So we have to solve that for constants a and b in identity 5x minus 4. This is identical to a of x plus 2 plus b of 2x minus 1. Now we're going to use the other method, the comparison method, to solve this question. So with the comparison method, we're going to expand, we're going to group, we're going to factor, and we're going to compare. Don't forget. So the first one, expansion, there's ax plus 2a plus 2bx minus b. Now you can factor out straight away if you feel comfortable with it, but if you don't feel comfortable, you can now group. So ax plus 2bx plus 2a minus b. This at this stage you can factor out. So I can say that I can write this one as let's say brackets open a plus 2b with x going outside plus now elements without x. In this case you can talk about 2a minus b. These elements, they don't have x to deal with. Sorry, this is supposed to be black. Yeah. Okay, now the left hand side of the equation, I can write this one as 5x plus 4. Oh sorry, minus 4. I nearly messed up. This one minus 4. Okay, at this stage we're going to compare the coefficients. So all x at the left hand side will be equated to expression with x at the right hand side. With this one, I can write this one as 5 is equal to, well, let me write the variables first. A plus 2b is equal to 5. I'm comparing the x to the left hand side to the right hand side. And with this one, negative 4 is going to be equal to a minus 2b. So I've got, 2a minus b is equal to negative 4. Now you solve this two simultaneously. You solve for a and b simultaneously, and that gives you your answer to the constants a and b. So solving this simultaneously, I think you're going to get a to be equal to -3/5 and b to be equal to 14/5. 14/5. Let's see if we got the same thing. If we didn't get the same thing, then it means we did something wrong. Yes, we got the same thing. B to be equal to 14/5 and a to be equal to -3/5. So that is solving for constants and identities. So I think the objective of the lesson has been achieved. Let's solve one more question and we say goodbye to this. A question that may require us to use both methods in the solving process. So let me get you a nice question to that one. Okay. This. Solve for constants a, b, and c in the identity x minus 1 is identical to a multiplying x squared plus 1 plus bx plus c multiplying x plus 1. So you can use any of the methods to start off this one. You can give this a try. We're going to solve it in about in the next 5 seconds. Pause the video and give this a try. Okay, welcome back. Let's use the cover-up method to finish up with this one. Now the first thing I can do is to eliminate this term, that is the constants b and c, by making x equal to -1 and this side. So when x equals to -1, or let me say let x be equal to -1. If x is equal to -1, this can be written as -1 minus 1 is equal to a of -1 squared plus 1 plus b of -1 plus c. Now x plus 1, or let me say -1 plus 1, this goes to 0. Simplifying this, I get -2 is equal to -1 squared is a positive 1, so this gives me 2a, and this term goes to 0. This term, the term goes to 0, because this term goes to 0. So with this, solving for a is equal to -1. Now the next thing to do is to eliminate another variable. In this case, I think when x is equal to 0, the b term goes away. When x is equal to 0, so let x to be equal to 0. So let x to be equal to 0. If x is equal to 0, the b term goes away. So this leaves us with something interesting. Let me take, okay, this gives us something like 0 minus 1 doing the substitution. This is identical to a of 0. 0 squared is 0, so let me just write 0 squared for explanation purposes, plus b of 0 plus c 0 plus 1. Now -1 is equivalent to, let me say, identical to a plus b goes to 0, c multiplying 1. 0 plus 1 is 1, and this simplifies to, let me shift this upwards. This simplifies to -1 is identical to a plus c. Remember, we solve for a and a is equals to -1. So we can do that substitution by saying that but a is equal to -1. Doing this, -1 is now identical to -1 plus c. Moving the -1 to the other side of the expression, transposing this one, this is going to get you c to be equal to 0. So far we solve for two variables. We solve for a and we solve for c. Now think through, how do you think we're going to solve for the next variable, that is the b? Can we eliminate a? Interestingly, we can't eliminate a. Whatever we do, we can't eliminate a because the squared over there, any number you substitute for x is going to come out to be positive. Now this positive plus 1 is always going to be a positive number. This is never going to go to 0. For a number to go to 0, 1 should be negative and 1 should be positive, and they should be the same number. So in this case, there is no negative number you substitute for x that is going to give you an outcome of a positive number. So we can now use the comparison method. You can use the comparison method. So let's write the expression over there so that we at least know what we are doing. What is the expression? I don't want to lose focus on it. Let me say lose track on the expression. So this x minus 1 is identical to a of x squared plus 1 plus b x plus c multiplying x plus 1. Okay, this was the identity. Now, like I said, in this case, we can't really eliminate a using the cover-up method. So that's where the cover-up method ends, because you can't eliminate this variable. For every value of x you substitute into this expression, you're always going to get a positive number, which is not 0 actually. Okay, so we need to think outside the box, or let me say think towards another direction. Let's try to use the comparison method. Using the comparison method, I get x minus 1. This is identical to ax squared plus a plus, we can expand this bracket, bx squared plus bx plus cx plus c. So what I'm doing is to use this bx to multiply the entire bracket, and use the c to multiply the other bracket as well. Now we can now group and factor. So ax squared plus let's say bx squared plus bx plus cx, and the constant term a plus c, that is those without the variable x attached to it. So I think my grouping is correct. I've got 1 2 3 4 5 6 and 1 2 3 4 5 6. Good, it's correct. Now on my left hand side, we can see that we've got only two terms, that is x minus 1, but on the right hand side we've got x squared term. So let's first evaluate this one. Let me say factor that one. A plus b out, and this is x squared. Now plus b plus c, factoring that one out as well, there's x, and finally those without x. This should go with this ink, I think, a plus c, so this is going with a green. Now right on the side, you can see that we've got x squared term on the right hand side of the equation, but you can't see any x squared term at this side of the equation. What we can do is, actually there is an x squared term, it says that you can see the x squared term is 0 x squared. So there is 0 x squared plus x minus 1 plus x minus 1. Now you can do the comparison. This, we compare that of the x squares at the left to that of the x squares at the right. If you do that comparison, we are going to get 0 is equal to a plus b, and also we're going to get b plus c is equal to 1, that is the coefficient of x, and finally I can say a plus c is equal to negative 1. Now 0 is equal to a plus b. Remember we solved for a, and we got a to be equal to where is that one? We got a to be equal to negative 1. So I can do that substitution over there straight away, so that I don't worry myself with any simultaneous equation. So we got a to be equal to negative 1. I can write this one as 0 is equal to negative 1 plus b. This gives me b to be equal to 1. This gives me b to be equal to 1. And also someone can decide to use this expression instead, where c was equal to 0. When c was equal to 0, you still get the b to be equal to 1, and you're good to go. Okay, so that is how to solve this question. This question was quite lengthy because it required us to use both methods in one same question. So you don't have any option here. You need to learn all the two methods. In some instances, you are to use all the two methods, but in instances where you have to use only one method, I will always advise you to go with the cover up method. It's faster, it's safer, and yes, I think it's easy to go about that one. Let's see if I can give you one to try at home. When we meet next time, we're going to talk about that. So we've gotten this one to be, we have to solve for the constants a, b, and c in the identity 2x minus 2. This is identical to a x minus 2 plus b x minus 2 squared plus c x plus 1. So you have to solve this identity, solve for the constants a and b, a, b, and c in the identity that. And when we meet next time, we're going to talk about the solution to this question. Thanks for watching this today's episode on MathFile. Like I said from the beginning, if this is your very first time of visiting the channel, please subscribe to the channel and don't forget to press on the notification bell. This is going to let you receive notification whenever I post new videos. You can also share the link, the group information, the link to your friends so that they can join on in the status. That's all for today's session. Stay blessed. Bye.